Hey guys, in the previous lesson we looked at answering question 7 part A, where we looked at filling out the cumulative frequency column here on my right. So in part B we're going to be answering by drawing the cumulative frequency curve. Now part B states that using a scale of 2 cm to represent 10 kilograms on the x-axis, so every 2 cm I'm going up by 10 kilograms, and 1 centimeters to represent 10 packages on the y-axis, draw the cumulative frequency curve for the data. And that's a 5 marks for that. That's a easy 5 marks, so you don't have to worry about it. Now here I have my graph leaf, and now let's just put in the information that they're asking us to fill in. They're saying that our scale on my x-axis, I'm going up by 2 centimeters to represent 10 packages. So here is my origin at this corner here. I would have my 0, and the first graduation here, that would be 1 cm. So I'm moving up 2, so here would be 2, and I'm counting up by 10, so that would be 10. So I'm going up 2 more, so this would be 20. Since I'm representing 2 centimeters to represent 10 units, okay. Then I'm going up by 30, then 2, I would go up by 40, then I'm going up by 50, okay, and then I'm going up by 60 there, okay. Let me just put in 70, and I think I can stop there, okay. Now I must label my axis carefully. So this is my x-axis, and up here my vertical axis, now this would be my y-axis, so I'm going to put a y there, okay. Now on my y-axis they have stated that I am going up by 1 centimeters to represent 10 units. So obviously here that's 10, and I would be going up by another centimeters, so that's 20, then this would be 30, then this would be 40, then 50, and I'm going up, this would be 60, then this would be 70, this would be 80, so this is 80, then I have a 90, so this is 90, then I have 100, okay. And I think I can stop there based on the information that I'm working with. Now this we have just filled out, or we have just put in the correct scales on our graph leaf. So now it's time to draw the curve, okay. Now if you notice what is happening here, let's just make a few quick pointers. As you can see, my x-axis and my y-axis are carefully labeled, okay. That's a error that students usually make, forget to do that, so please don't do that in the exams now for me, okay guys. Now if you notice again, my graph, it has a title. It states cumulative frequency curve showing the distribution of the masses of 100 packages, okay. So always ensure that each chart that you're drawing has a title, okay. That's another important thing. Now when drawing a cumulative frequency curve, let me just pull this over a bit, okay. What you're really plotting, you're plotting cumulative frequency on your y-axis. So on my y-axis here, I must have my cumulative okay, frequency, and this is frequency, okay. So I'm plotting cumulative frequency against my upper class boundaries. So down here I must have my upper class boundaries. So as I've stated, when on my graph leaf, I'm plotting my cumulative frequency here on my y-axis, okay, along with my upper class boundaries, which represent my masses in kilogram on my x-axis. So quickly we need this information now to fill out to draw the curve. So let's just quickly scroll back up so that we can get this information. Now to get my upper class boundaries, if you notice, I have constructed another table here on my right. So I'm plotting my upper class boundaries as we have stated previously against my cumulative frequency. Now, if you notice, I'm going to be taking these values here. When you look at my mass column in kilograms, these values to the extreme right, okay, these values, well, let me just introduce something to you. These are called class intervals. So in my class intervals, in each class interval, you have a upper class limit and a lower class limit. So what I'll be taking, I'm going to be taking the upper class limits of each class interval. Okay. So here I'm going to, for the first one, I'm going to take the 10 up top here. Okay. So I'm saying 10. And to get my upper class boundary, I must add 0.5 to 10. So that would give me a 10.5. So 10.5 is my upper class boundary for the first class. Okay. Then again, I would continue that process. I would say 20 plus 0.5, and that would give me a 20.5. And then I'm taking the 30, and I'm saying 30 plus 0.5, and that's equal to a 30.5. And then I'm taking 40 and adding 0.5, and that is equal to 40.5. And then I'm taking 50 and I'm adding 0.5, okay, and that would give me a 50.5. Okay, now let's just quickly separate these quickly, and let me show you what is really happening now. Okay guys, let me just draw this line and get that out of the way. Okay, so this can look a little bit more organized. Now if you notice, in the second row, I have 10 here in my first class, so 10.5 here would be plotting with the 12 under my cumulative frequency. So I would have a 12 there. Then I would have my 40. If you notice how I'm coming down in my cumulative frequency column, I'm matching each row as I go down. Okay, so over here now I would be plotting 30.5 with 70, then I would be plotting 40.5 with 92, and then I would be plotting 50.5 with 100. Okay, so that's it. Let's just copy this and take it down so that we can draw a curve quickly. So let's just quickly scroll down and take our table with us so that we can quickly draw our cumulative frequency. So let me just pull this up a bit. So let's paste this here. Let's just paste this here quickly. Okay, so here we have our nice little column working with. Okay, and just if you are curious, our cumulative frequency, or OGIVE, as it is otherwise known, it has this general look. Okay, and let me just do a quick sketch here. Let's say that's my Y. So let's say this is my y-axis and this is my x-axis. This would be my origin, 0. So my cumulative frequency curve, it has a S shape. So it should be looking something like this. Okay, that's a general shape it takes. Now quickly, let's move. I am going to be plotting these values now on my axis. All right, so here I'm plotting 10.5 with 12, but first, before we get into that, I think we should work out the scale. Okay, because for each of these little gradients that we're going up, you need to know how many you are increasing by or decreasing. So let's check. If you notice, and let me just we can take this area, for example, between, let's say, 60 and 70. Okay, let's just take that little area. If you notice, to move from 60, let me just change my pointer, to move from 60 to reach the 70, you have 1 2 3 4 5 6 7 8 9 10. You have 10 little bars that falls in between 60 and 70. So I mean, you need to know how many you're increasing by. So let's check the scale, how to work out the scale quickly. So to work out my scale, okay, I'm just going to make a note here. My scale will be equal to, since there are 10 of them in between 60 and 70, then that 10, that number, whatever that number is, it goes in my denominator. And I'm looking at the scale now. If you notice, I'm increasing by 10 also. From 0 to 10 is 10, for example. From 0 to 10 is 10, then to 20 it's another 10, to 30 it's another 10. So obviously I am going up by 10. So the amount that I'm going up by, that goes in my numerator. So that would be equal to 10 into itself goes once, and 10 into itself again goes once. So 1 over 1 is the same as 1. So what this is really saying is that I am increasing each of these little graduation that I'm going up by, these little bars here in between, and on my x-axis I'm going up by 1. Okay, now you could check it for your y-axis, same procedure, but on my y-axis, each bar that I'm going up by, since it's 5 in between, I would say 5, and since I'm increasing by 10, that would be 10 over 5, which is 2. So I would be increasing each little bar that I go up, I would be increasing by 2, okay, on my y-axis. So let's just plot this quickly. And after we are through plotting, we're going to draw our smooth curve. Now let's just take out these values. I am matching 10.5 on my upper class boundaries. I am matching 10.5 with 12. So on my upper class boundaries, which is my x-axis, I must find 10.5. Now if this is 10 and I'm increasing by 1, then 10.5 would be exactly between 10 and 11, somewhere here, and I'm going to plot that with 12. So I am going up and I'm going to stop right there, because this would be 12, okay, on my y-axis. All right, so this little line there, that would be 12, because I'm increasing by 2 on my y-axis each little bar I go up. Okay, now moving on, I'm plotting 20.5 with 40. So I'm going up 20.5, which would be here, and I'm stopping on my 40 line. Okay, so that's right there. Okay, that's good. And then I'm plotting 30.5 with 70. So I'm going up on my 30.5 and I'm going to stop at 70. Okay, that looks pretty good. So exactly on that line I'm stopping right there. Then I'm plotting 40.5 with 92. So I am looking for 40.5 on my x-axis rather, and I'm going up to 92. So the first one here would be 92. So 92 is approximately right there. And then I'm going to be plotting 50.5 with 100. So let's go up again. So this would be 50.5 and I'm stopping on 100. So exactly right there. So that seems pretty good. So guys, after completing plotting our points, it's now time to draw our curve. Okay, so I'm going to start from my origin, and I am going to draw a smooth curve straight through all of these points. Your curve should be as smooth as possible. So I'm going up through that point. Let me stop there a bit. Then I'm going to go up and I'm going to come around like this. Okay, so that's the general shape of my cumulative frequency. Okay, it's that easy. As I have said, when you're drawing a cumulative frequency curve, we plot upper class boundaries against cumulative frequency, and as you can see it on our diagram here, let me just scroll over a bit. We plot cumulative frequency here on my y-axis and against my upper class boundaries on my x-axis. Stay tuned for part C in the next video. Okay, bye bye.